Hello, welcome to Mr. CFD. In this video, we will analyze and discuss the results of the CFD product UAV External Airflow in ANSYS Fluent software. According to pressure control, high pressure regions are visible at the leading edge of the wing and the nose of the fuselage. A low pressure region is observed above the wing, consistent with lift generation. Actually, the pressure distribution aligns well with aerodynamic theory, showing high pressure at stagnation points and low pressure over lifting surfaces. Or we can say the pressure difference between the upper and lower surfaces of the wings confirms that the UAV is generating lift as expected. Let's take a look at velocity streamlines. The streamlines show the flow pattern around the UAV. As mentioned in the description of this product, the maximum velocity is about 43 meters per second, while the free stream velocity is 30 meters per second. This acceleration of the flow is visible, particularly over the wings. Speaking of flow acceleration, we can say the increase in maximum velocity from 30 to 43 meters per second over the wings is significant. This acceleration contributes to lift generation but may also increase drag. Also, the streamlines remain mostly parallel and undisturbed, far from the UAV, which is expected. There is some flow disturbance visible behind the UAV, indicating the wake region. About the wake region, we can say the disturbed flow behind the UAV indicates a wake region, which is normal but contributes to the overall drag of the vehicle. The CFD analysis provides valuable insights into the UAV's aerodynamic performance. These results can guide design improvements to enhance efficiency. Future simulations across various flight conditions will help ensure the drone performs well in all intended situations. Hope this video is helpful for you. To benefit from Mr. CFD services including simulation, consultation, and training, visit our website www.mrcfd.com or contact us via info@mrcfd.com.